Namaste friends, my name is Satoshi and today we will talk about number systems. We will see what it means by the base of a number and try to understand the basic concepts of the decimal number system. The number system used in our day-to-day life is called the decimal number system. The word decimal is derived from the Latin word decimus, meaning tenth. The combining word deca is often used as a prefix for 10. For example, a decahedron is a solid figure with 10 plane faces. A decameter is equal to 10 meter and a decaliter is equal to 10 liter. So why decimal? Let's look at the unique digits we use to construct our numbers. 1 to 9. But wait, that's 9 unique digits, right? Yes, but we forgot the 0. So 0 to 9, that is 10 unique digits. Also, it's interesting to think that it's easy for us to use the decimal number system because we have 10 fingers. So let's say I gave you a box. You can only write a single digit number in the box. How many different possible numbers can you write in the box? Give yourself a moment and think about it. Okay. 10, right? You can have 10 different ways of filling up this box. So each time you can either write a 0 or a 1 or a 2 or a 3, so on until 9. So one box, 10 different ways of filling up. Now let's say I gave you two boxes. You can only write a one-digit number in each of these boxes. How many different possible numbers can you represent using these boxes? 100. You can have 100 different ways of filling up these boxes. That is 0 to 99. Let's generalize this concept now for n boxes. So we saw how many combinations we can build with one box, with two boxes. And now the number of boxes is a variable. How many different possible numbers can you represent using n boxes? With one box we saw 10 combinations. Now I want you to understand that we can represent this concept using 10 to the power 1. 10 to the power 1 means 10 multiplied once. With two boxes we had 100 combinations, that is 10 to the power 2. 10 to the power 2 essentially means 10 multiplied twice, that is 10 into 10. So a to the power b means a multiplied b times. So with n boxes we can have 10 to the power n combinations, that is 10 multiplied n times. So to summarize, we can represent exactly 10 to the power n different types of information using n boxes. Let's see a special case now where we had 0 boxes. How many different types of information do you think we can represent using 0 boxes? Any number except 0 to the power 0 is 1. So I want you to remember any number to the power 0 is 1. 1 to the power 0 is 1, 2 to the power 0 is 1, 3 to the power 0 is 1. Any number, so 10 to the power 0 is 1. The only special case, the only exception is 0 to the power 0 is undefined. We cannot represent this number. And for this lesson, we will not talk about 0 to the power 0 because we don't need it. So, 10 to the power 0 is 1. Now you don't have any boxes, that is, you have 0 boxes. So with 0 boxes, you can represent exactly one piece of information, that is 0. Believe me, for now, that 10 to the power 0 is 1. Now, let, let us look at the expanded form to understand the decimal number system a little better. Let us take an example, the number 734. So one more way of writing the number 734 is 734 to the base 10. When dealing with number systems, we use this notation to reinforce the fact that we are dealing with a decimal number. Going forward, we shall see other different types of number system where we will use a base other than 10. So when we look at this number 734, essentially we are saying the least significant digit 4 has a face value of 4 and a place value of ones, 1, that is 10 to the power 0. The number 3 has a face value of 3 and a place value of 10, that is 10 to the power 1. The number 7 has a face value of 7 and a place value of 100, that is 10 to the power 2. So you start counting from the rightmost bit and you assign a place value of 10 to the power 0, 10 to the power 1, 10 to the power 2, so on and so forth. So essentially, you start assigning place value in the power of 0. So we represent 4 as 4 into 10 to the power 0, 3 as 3 into 10 to the power 1, and 7 as 7 into 10 to the power 2, which is essentially 4 into 1, 3 into 10, and 7 into 100. We add these three numbers and we construct our number 734. Well, that is it for now, friends. In an upcoming video, we shall see the binary number system. Until then, goodbye and take care.